Alright, good day everyone. So welcome back to my YouTube channel, and this is Kasaligan Vlogs. Today we'll be talking about double and half angle identities. So trigonometry. So good luck and God bless, because I'll be teaching to you how to solve problems like this. So we have here the double and half angle identities with power reducing formulas. So take note of these double angle identities. I also included the power reducing formulas here because they're somewhat like related. So we have here some sine 2a is equal to 2 sine a cos a. For half angle identities, we have sine a is equal to positive and negative. The square root of 1 minus cos a over 2, because sine a, we would have to determine in what quadrant would be the sine a would fall. And we have power reducing formulas as well, because we could write it one in the double angle identities. Okay, so we have your double and half angle identities. So let's take first problem number 1. So given cos theta is equal to 3/5 and sine theta is lesser than 0, and find sine 2 theta, cos 2 theta, and tangent 2 theta. So let us have first problem number 1. Right, so let's just have to solve here. So cos theta is equal to 3/5 and sine theta is lesser than 0. So therefore, I understood that our sign here is a negative sign. So we have here cosine 3/5. So in order for us to get we have cosine theta 3/5, we need to find first, in order to get sine 2 theta, cos 2 theta, and tangent theta. So by the way, the formula for sine 2 theta, so given that we need to get for 2 sine theta and cos theta. So in this case, we need to get sine theta because we have already cos theta. Next, we have cosine 2 theta is equal to 2 cosine squared theta minus 1. So no need to get sine theta here because we have already cosine squared theta. For tangent theta is equal to 2 tangent theta over 1 minus tangent squared theta. You can have also sine 2 theta over cos 2 theta, right? Because this is 2 theta. Tangent 2 theta is equal to sine 2 theta over cos 2 theta. So let's have first in solving for our sine theta. In order for us to get for sine 2 theta here. So we have here in finding the sine theta. So sine theta is by the use of identities. We have sine squared theta plus cos squared theta is equal to 1. So sine squared theta plus this is the result of this one is 3/5 given, then squared is equal to 1. So we have here the answer. Sine squared theta is equal to 1 minus 3/5 squared. So sine theta is equal to the square root of 1 minus 9 over 25. So if this is 9 over 25, so sine theta is equal to, you could have this one as 25 over 25 minus 9 over 25, positive and negative. So sine theta is positive and negative. The square root of 25 minus 9, that is equal to 16 over 25. So therefore, positive and negative, 4 over 5. Since sine theta is lesser than 0, so therefore sine theta is equal to negative 4 over 5. So this is the result of our sine theta. So to find for sine 2 theta here, so the formula that I introduced is 2 sine theta cos theta. So sine 2 theta is equal to 2 sine, our theta is 2 sine theta and cos theta. Let's just copy here. So 2, which is negative 4 over 5, times we have cos theta is equal to 3/5, right? That is 3/5. Okay, so 3/5. So we have here negative 4 times 3, 12, negative 24 over 25. So this is our sine 2 theta. So negative 24 over 25 because 5 times 5. So check number 1. So next we have here cos theta. So cosine 2 theta is equal to 2 cosine squared theta minus 1. So since given our cos theta is equal to 3/5, so 2 over 3/5 squared minus 1. So we have here 2 times 9 over 5 minus 1, 25 rather. So we have here 18 over 25 minus 25 over 25. So 18 minus 25, that is equal to negative 7. So cos 2 theta is equal to negative 7 over 25. So this is the value for our cos 2 theta. To find for tangent theta, we have the two formulas. 2 tangent theta is equal to sine 2 theta over cosine 2 theta. So given here, sine 2 theta is equal to negative 24 over 25 over negative 7 over 25. So cancel here, the negative as well. So therefore, tangent 2 theta is equal to 24 over 7. That's the answer for tangent 2 theta. But if we're going to use the identity, which is tangent 2 theta is equal to 2 tangent theta over 1 minus tangent squared theta. If we're going to make use of this identity, just simply substitute here. So we have here the answer. So 2 times, we have negative, what is tangent theta? So tangent theta, if we're going to solve this one, we have tangent theta is equal to, sine here is negative 4 over 5 over the cosine is 3/5. Okay, so cancel here. So therefore we have negative 4 over 3 because the remaining is 4 over 3 over, so 1 minus negative 4 over 3 squared. Okay, so tangent 2 theta, if we're going to simplify that one, we have negative 8 over 3 over, this is squared, 16 over 9. So 9 over 9 minus 16 over 9. So if we're going to equate this one, negative 8 over 3 over, what is 9 minus 16? That is equal to negative 7 over 9. So cancel negative. So we have, the result is 8 over 3 times 9 over 7. Okay, so we have here 3. So we have 3 times 8, that is 24 over 7. So we have here the same answer if we're going to make use of your identities. Okay, So since that is also an identity, so we can make use of this one because given sine 2 theta and cos 2 theta. Okay, so stop. Try this number one. Use identity to find the values of sine function. Theta given cos 2 theta is equal to negative 5 over 12. And the theta is between 90 degrees and 180 degrees. So stop. Try this one at home. So please solve this one. So we are now in problem number 2. So cosine S is equal to 2/3 with 3 s is equal to s is greater than 3 over 2 and s is lesser than 2 pi. So first thing that we're going to do is we have to, since we need to find the half angle identities for this part, we have to divide the angle into 2. And this one is divided 2 and this one is divided by 2. So if we're going to divide it by 2, so we have here, divide 2, we have 3 pi over 2, take the reciprocal of this one, you have 4. And s over 2 is, we have lesser than pi. So this would now be the new case because we have to get the half of the angle. If we're going to illustrate that one in the first step, okay, so we have to find here cosine 2 over 3 and versus 48. Okay, so 48. So since between here, okay, adjacent here we have here, okay, this part, this is your S. Since you divide it by here, so we have 3/4 is 135 degrees. So in this part, okay. So this is our S over 2 now. So since this part, okay, if we're going to create here, we have the reference angle, and also for this part as our reference angle that is less than 90 degrees. So you need to find this side. Okay, so we have to find this side. So we have here the formula for sine S and cos S. So first thing that we're going to do is we need to find sine S over 2. So given, which is cosine S 2/3. Okay, so the first we have sine. So sine S over 2 is equal to positive and negative the square root of 1 minus cosine S over 2. Okay, so we have here what we are going to choose in sine pi S over 2. So sine, this is, if this is the case, the sign here is positive. So therefore, we'll make use of positive here. So plus the square root of 1 minus the cosine is over 2/3 over 2. Okay, so plus here the square root of 3 over 3 minus 2 over 3 divided by 2. Last, we have here 1/3 over 2 that is equal to plus the square root of 1 over 6. So we have to take the reciprocal of this one. Now that the conjugate of this one rather. So we have here the square root of 6 over 6 by rationalizing. So therefore sine S over 2 is equal to square root of 6 over 6. So next we have, next problem is cosine, half angle cosine, okay, over 2. So cosine S over 2 is equal to, cosine at this time is, what is the cosine? Cosine is adjacent over the hypotenuse. So this one is negative and that plus positive, so therefore the cosine in the side is negative. Okay, with half angle identities now, because the cosine last time is positive, but since this is an half angle identities, this is negative. Okay, negative the square root of 1 plus cosine s over 2. Okay, so negative the square root of 1 minus 3 halves over 2 plus 3 halves. So we have here negative the square root of 2 over 2 plus 3 over 2 over 2. So negative the square root of 5 over 2 times the reciprocal is 1, 3 over 2. Ah no, that is 2/3 rather, 2/3. 2/3. So therefore 3 over 3. Alright. So 3 plus 2, that is 5 over 2 times the reciprocal of this one is 1/2. So therefore negative square root of 5 over and this is 2, 3, 6. The square root of 6, right? Why is it the square root of 6? Because 3 over 3, 5, 3 plus 2, that is equal to 5 over 3. So take the reciprocal of this one is 5 over 6. Over square root of 5 over 6, you have to take the conjugate for this part, rationalizing rather. So you have 6 over the square root of 6. So cancel this part. So we have negative square root of 30 over 6. So this is our cosine s over 2. Now we are now in tangent. So we have here tangent. So tangent s over 2 is equal to sine s over 2 over cosine s over 2. So we have 2 simplify square root of 6 over 6, which is a sine, over negative square root of 30 over 6. So cancel this part. So negative. So we have here square root of 6 negative over square root of 30. So rationalizing, we have square root of 30 over the square root of 30. So we have here negative square root of 180 divided by 30. So 180 could be have negative square root of 36 times 5 over 30. Alright. So they have 36, that is negative 6 square root of 5 over 6 times 5 to make it 30. So cancel. So we have here negative square root of 5 over 5. So this is the answer. So this is the answer for formula number 2. So we have here, try this, number 2. So find tangent theta over 2, that's sine theta is equal to 3/5, and the condition is theta is greater than 90 degrees and lesser than 180 degrees. So let's proceed now with number 3. In number 3, the problem is find the exact value of cosine 15 degrees using half angle identities for cosine. So cosine is equal to cosine 15 degrees is equal to, we can have cosine 1/2, 30 degrees is equal to the square root of 1 plus cosine of 30 degrees over 2. So we could express in this way. So first is we need to find for cosine 30 degrees. Okay, if this is the angle, so we have here, okay, if this is 30 degrees and this is 60, so the opposite of this one is 1/2, and this is the radius of 1. To solve for this one is x squared plus y squared is equal to 1. So x squared plus y is 1/2 squared is equal to 1. So we have here x squared is equal to 1 minus 1/4. Okay. X is equal to the square root of 4 over 4 minus 1/4. So now we have here, if we're going to equate this, so we have x is equal to the square root of 3 over 4. So x is equal to the square root of 3 over 4 square root times the square root of 4 and square root of 4. Okay, square root of 4. Okay, x is equal to, we have the square root of 12 over 4. So we can factor this one as 2 square root of 3 over 4. So cancel this part, we have square root of 3 over 2. Okay, so we have here the cosine 15 degrees. So we have now cosine 30 degrees is equal to adjacent, which is square root of 3 over 2 over the hypotenuse square root of 3 over 2 over 1. That is our cosine 30 degrees. Okay, so cosine 30 degrees is equal to square root of 3 over 2 because adjacent over the hypotenuse, which is 1. So now in the problem, so we have here cosine 1/2 30 degrees is equal to the square root of 1 plus cosine 30 degrees over 2. So we have the answer. The square root of 1 plus the square root of 3 over 2 over 2 is equal to the square root of 2 over 2 plus the square root of 3 over 2 over 2. So we have the answer, the square root of 2 plus the square root of 3 over 2 over 2. So take the reciprocal of this one, you have the square root of 2 plus the square root of 3 over 4, because if we're going to take the reciprocal, so we have the square root of 2 plus the square root of 3 over the square root of this one is 2. So therefore, this is the answer. The square root of 2 plus the square root of 3 over 2. Okay, so stop, try this at home. So find the exact value of tangent 22 degrees and 5 minutes using 5 degrees using the identity tangent A over 2 is equal to sine A over 1 plus cos A. So we are now in the last part. We have problem number 4. So problem number 4, verify the following equation as an identity, and letter B also, A and B. Let's have number 1. So in number 1, so we have cot x sine 2x is equal to 1 plus cosine 2x. So we have cot is equal to cosine x over sine x, and sine 2 theta is equal to 2 sine x cos x is equal to 1 plus cos 2x. So cancel this part, so therefore we have 2 cosine squared x is equal to 1 plus cosine 2x. So we have here cosine 2 cosine squared x is equal to 2 cosine squared x minus 1 is equal to cosine 2x. So therefore, if you're going to equate this one, so 2 cosine squared x is equal to 1 plus cosine 2x. Therefore, 1 plus cosine 2x is equal to 1 plus cosine 2x. So check here. So we have here number 2. In number 2, we have here the problem. So sine x over 2 plus cosine x over 2 squared is equal to 1 plus sine x. So by the use of a plus b squared is equal to a squared plus 2ab plus b squared. Algebra identities niya. So we have sine squared x over 2 plus the product of a and b. We have 2 sine x over 2 cosine x over 2 plus cosine squared x over 2 is equal to 1 plus sine x. So cosine squared x over 2 and cosine squared x over 2 is equal to 1 by the identities plus 2, and this is 2 sine x over 2 and cosine x over 2, that is equal to sine 2a is equal to 2 sine a cos a. So since this is x over 2 and x over 2, understood that we have 2 sine, no, this is sine 2 times the value for a is x over 2 is equal to 1 plus sine x. So 1 plus, cancel this part, is sine x is equal to 1 plus sine x. So check. So that's the identity for number 2. So problem number 4. Stop, try this. Verify the following equation is an identity. So sine squared x over 2 half angle identity is equal to tan x minus sine x over 2x, 2 tan x. B is equal to 2 over 1 plus cos x minus tan squared x over 2 is equal to 1. So thank you so much for listening, and I hope everyone, so you are looking at my videos. We have 1 to 4. Stop, try this. So do not forget to subscribe and do not forget to comment down your answer. So thank you so much, and God bless.